Hi, my name is Carolus. I'm a freshman in CS at U of I.
Hi, I'm Julian Cha, a freshman in CS in U of I.
My name is Tian Yi, and I'm a senior in economics at UFI.
My name is Jackson Clark, and I'm a sophomore studying data science at UIC.
So, we made a machine learning project called Farm Atlas. So, before we get into what Farm Atlas is, the problems we wanted to address in our project were overcultivation, scarcity in developing nations, and need for more food as population is growing. So what is Farm Atlas? Farm Atlas is a deep learning based project that tries to find unutilized farmland which can be used for growing crops. So how does Farm Atlas address these issues? Well, if we can find unutilized cropland, we can use that cropland to get more food to these underdeveloped nations, and we can stop overusing land that we've been using in the past and start using new land.
So, how did we actually make our model that actually does this task? So, we went through 5 steps. The first step is data collection. Data collection step is basically deciding what factors to consider in our model, and we actually searched and found the data sets that we were going to use. The second step is feature extraction, where we were processing useful information like feature vectors from the collected data. Then we moved on to the third step, which was model construction. We built a deep learning model using PyTorch library. Then the fourth step, we trained the model. We trained the deep learning model and modified the parameters to improve the training process. Then lastly, we went through the prediction step, which was making prediction of test data using the trained model and visualizing the results. So we used a lot of data sets. The most important data set was the crop ground truth data, which tells us where the crops are grown in the world. And we used 4 types of feature data. First one, soil temperature. Second one, the surface solar radiation. Third one, temperature above ground. And fourth one, precipitation. They were all in forms of heat map that was provided by Google.
And now we're going to give you a little demo of how our project works.
That's probably 3 minutes.
All right, so as you can see, there's a grid layout interface over an existing map. So the reason we chose this is that way we can choose relevant segments to give to our machine learning model, so that way we can get relevant output. Because the Earth is a little too vast for our model to accurately calculate that for everywhere. So this is how we choose our segments. So conveniently enough, the tiling system that Google Maps, Bing Maps, and all the big mapping companies use actually fits our model pretty conveniently. So we were able to find a method for calculating those tiles, and then we were able to use an HTML canvas to display that grid over the values.
So after getting coordination from the front end, we further divide the region into 4 subregions to output more like details to identify if the land is suitable for growing crops or not. So we like again getting all of these different maps, precipitation, solar radius from Google Earth Engine, and then construct a feature vector and feed it into our model, into our machine learning model. And we after we have the outputs, we just decide the green will be the green means this land will be suitable for growing crops, while red means it is not suitable for growing crops. Because we divide the regions into 4 subregions, it will output more details, like so you can see some parts can be red and some parts can be green.